Good morning, everyone. My name is Jim Chastain. I'm hosting today's session. Welcome to the EasyPower Thursday webinar series. And my primary function is to introduce our guest speaker. Our guest speaker is well known to the industry. Among his many responsibilities, he is Vice Chair of the IEEE 1584, generating the Guide to Performing Arc Flash Calculations documentation. He's the International Chair of the Geneva-based International Electrotechnical Commission, which are working on IEEE 78. He's a member of the Technical Committee of NFPA 70E, Standard for Electrical Safety in the Workplace, and he's on the steering committee for the IEEE NFPA Arc Flash Collaborative Research Project. He's founder of brainfiller.com. And he's a thought leader in the industry today. We are privileged to have Mr. Jim Phillips join us. So again, thank you all for attending.
Hello, everybody. Greetings from Arizona. Glad you could all join in here. What I'm going to do over the next hour is we're going to take a look at some of the major changes to the 2021 edition of NFPA 70E. Before I get started, I have a disclaimer that I need to provide, and that's simply that I am very involved with a lot of different codes and standards. I'm on the NFPA 70E Technical Committee. I am the Vice Chair of IEEE 1584. That's the Arc Flash standard. I'm the International Chair of all the IEC live working standards. That's about 40 different standards and publications represented by, I think we're at about 41 different countries. So I'm pretty deep into this. So I'm required to state that what we're going to talk about, all these views, they're mine. They don't necessarily represent any particular standards organization. And with that, let's get going. A lot happened since 2018. NFPA has a 3-year revision cycle, so it's been 3 years since the last edition was published. And between 2018 and 2021, a lot has happened during this time frame. We had, for the first draft, we had 332 public inputs. Now, you may think of these as proposals, but they're technically public inputs. So we had 332 that led to 86 first revisions, and then we had the second round. The second draft had 115 public comments, and that led to 43 second revisions, and that is what took us to 2021. The last time that we met was in Indianapolis last summer, and that was just to finalize a few things. And then after we met, then everything went off to publication, and early September of this year, 2020, we have the latest and greatest edition of NFPA 70E. Yes, you can get this from the NFPA website. You can get it from Amazon, and there are quite a few changes in this document that we're going to take a look at. One of the things that I've been mentioning for a couple of years is that this has become, my opinion, a pretty stable document. In the early years of NFPA 70E, it was kind of like they were triangulating, you know, let's go that direction, and then another edition, now let's kind of go that direction. And it's been pretty stable since around 2015, 2012, 2015. And so because of that, the changes that we have, there are a few significant changes, but a lot of it is just tightening up language and modifications and reorganizing. Oh my goodness, that's a lot of what happened this time around, was a lot of reorganizing with NFPA 70E. Have a kind of a rhetorical question for you, but it's an important question still the same. What's the most important aspect of electrical safety? And I'm sure you're thinking, well, it's about the electrical hazards, and actually it's the elimination of the electrical hazards. And this is a big focus with the 2021 edition. We all know about establishing the electrically safe work condition, and that's been elevated to yet an even higher orbit in the 2021 edition, as we're going to see. I want to first talk about a couple of changes to definitions, and you might think, oh, good heavens, are we going to talk about definitions like a junior high vocabulary class? No, but from my experience, definitions can become an important part when you're addressing interpretations of certain requirements. What does this term actually mean? So there were a couple of modifications and changes that I want to talk about. First off, some of the definitions that we had in 2018 were just deleted because it was discovered that, we're really not using these. We have definitions of these terms, but they're not used in NFPA 70E, so they were just simply deleted. And some were changed to align with the National Electrical Code. You have the same term in two different standards, and you have slightly different definitions, so it was time to sync these up. One definition that had a minor change was the word balaclava. And so balaclava, you're familiar with the balaclava, it used to be called a balaclava hood, and the term hood and sock were used in the definition. And it was recognized that, those terms aren't really applicable. Calling it a balaclava sock hood, it's now been changed to an arc-rated head protective fabric that protects the neck and head, except for a small portion of the facial area. That's actually a picture of me. And it was simply just a matter of, it's not really a sock, it's not really a hood, so just a simple change to the definition of balaclava. Another adjustment, we'll call it, was with the definition of barrier. There was language in there that said it was to prevent unauthorized access to a work area. That's not really what was meant by this term barrier. In fact, in 130.7D2, the term barrier is also used, so the language or to prevent unauthorized access to a work area was simply deleted, so that this syncs up with the other location in NFPA 70E. The definition of electrically safe work condition. This is the main focus of NFPA 70E. This definition had a note added, and it was to emphasize the word condition. And to really explore this in more detail, I thought, well, let's take a look at what the dictionary has to say about the word condition. And it's a state. The word condition is a state. And that is where the emphasis is within NFPA 70E, that there is a new informational note that was added to emphasize the electrically safe work condition. It's not a procedure, it's a state. And so this is for that emphasis. Now you might be thinking, well, what about the procedure? I mean, do we still have the procedure in there? The procedure's still there. It's actually been divided into two areas now, two parts, where we have the state, this is an electrically safe work condition. This has been placed into an electrically safe work condition, but we still have the procedure. And the procedure, there were a few changes made with the procedure, actually just word modifications, and we'll see that here in a little bit. Arc-resistant equipment. The change here was to align with what we have today. This originated as arc-resistant switchgear many, many years ago. But since then, there is more than switchgear that is arc-resistant. So this was changed simply to arc-resistant equipment. And an informational note was added that references the standard for testing the switchgear for internal arcing faults. So there's a new informational note referencing the appropriate standard. And there's an Annex O that's for safety-related design requirements, and arc-resistant equipment is referenced there as well. In fact, something that I want to kind of give you a heads up, there's a standard that's in development. It's an IEEE standard, and I'm part of this working group as well. Just kind of an FYI coming down the road, there's a standard in development called IEEE 1814. And we just refer to it as it's electrical safety by design. So optimistically, I would hope that that standard might be out within the next year or two, but the IEEE procedures kind of go slow, so it may be a little longer than that. But there's actually a formal standard that'll be coming out, IEEE 1814, and it will give you methods and so forth for electrical safety by design. The shock hazard, a minor modification with the shock hazard. The word exposed was added. And the word exposed is actually kind of important because somebody would walk by a panel and think, oh, does a shock hazard exist? I don't know. Do you have exposed energized conductors? So that word was added, and there actually is a reference that the word exposed is capable of being inadvertently touched or approached nearer than a safe distance by a person. So there is a reference to the word exposed. Nominal voltage. This was a little bit of cleanup, we'll call it, that NFPA 70E is applicable for systems 50 volts and greater. And so there was always this question, what about battery systems? Battery systems rated, for example, 48 volts nominal. It's like, well, that's less than 50 volts. Yes, but they can have a charging float voltage upwards of 58 volts. And so the question was, well, how do you handle that? So there was some language added just referring to DC applications where 60 volts is used to cover the entire range of float voltages. Article 110, a lot of reorganization to Article 110. And the reason for this, 110 is considered the most important article because that gives you all of the general requirements. The way NFPA 70 is organized, 110 defines the general requirements. 120, that defines the requirements for lockout, tagout, and basically establishing the electrically safe work condition. And then 130, okay, if you're going to have to perform energized work, well, here's how you do it. These are the requirements in 130. So some of the information in both 120 and 130 general requirements were relocated into 110. What we had in 2018 is 110 actually had 7 sections to it. And you could see them on the left: electrical safety program all the way up through overcurrent protection modification, 110.1 through 110.7. These were all renumbered, and they were renumbered as 110.5 through 110.11. And so you may think, okay, so what about 110.1 through 4? Great question. 110.1 through 110.4, this is information that was relocated from other parts of NFPA 70E. Priority, general requirements, electrically safe work condition, and energized work. So those were relocated and now occupy 110.1 through 110.4. And we had another entry, 110.12. This is new, and this is for equipment use, which I'll show you here in a little bit. A relocation of priority was very important. This used to be in 105.4, and it was actually added in the 2018 edition of NFPA 70E. But it's considered to be so important that it was relocated to 110, and not just relocated to 110, it was relocated to 110.1, the very first section in 110. It is that important. Hazard elimination. It's the first priority in the implementation of safety-related work practices. So electrically safe has been elevated, as I mentioned, to a much, much higher orbit. There was a new informational note that was added, differentiating between an electrically safe work condition as being a state or the requirements. And this informational note states that the condition is the state, and that was also captured in the definition. The requirements are still in Article 120. So we have the condition in 110 now, and we have the requirements to establish the electrically safe work condition still in 120. The electrically safe work condition, when it is required, has been moved to 110. 110.3, electrically safe work condition, this was relocated to again prioritize, to put a greater emphasis on the electrically safe work condition. And the electrically safe work condition in 110.3 now defines when the condition is required to be established. It doesn't tell you how. That's still in 120. We still have the same concept. You establish an electrically safe work condition if the employee is working within the limited approach boundary or if they're interacting with the equipment. That word interaction, you may remember that back in 2009. The 2009 edition of NFPA 70E changed the definition of an arc flash hazard from exposed energized parts and conductors to also include if you're interacting with the equipment in such a way that could lead to an arc flash. What that involves is if you have a switch, for example, this was back in 2009, simply just interacting could be considered an arc flash hazard. And that really caused a lot of confusion. Like what I just did, just operating the switch could be considered an arc flash hazard. Back in 2009, the answer was yes. And then in 2015, there was a table that was added to help clarify that. And now in 2021, it's become pretty stable. There is a new addition to interaction possibly being an arc flash hazard, and we'll take a look at that later on. The electrical safety program. There was some language that was removed, and this has been an ongoing trend within NFPA 70E. 70E used to directly reference other codes and standards, and they've been removed. And so at the direction of the correlating committee, there was a direct reference to health and safety standards. This has now been moved to an informational note. There was a direct reference to the employer's overall occupational health and safety management system, if one exists, and this has now been moved to an informational note. And also, there's an informational note that references Annex P that is to align the implementation of this standard with occupational health and safety management. Human error. This was tightened up a little bit. Now, this is something that you'll see a few times throughout the 2021 edition, that some of the language that was out there to begin with, the original language, was kind of broad. For example, the definition of human error is the potential for human error and its negative consequences on people, processes, the work, environment, and equipment. Wow, all equipment, all processes, that was a pretty broad requirement. And so this was tightened up a little bit, and it now adds relative to the electrical hazards in the workplace, to tighten this up and aim the focus exclusively on the electrical hazards. Job safety planning. There is an informational note that now references a job safety planning checklist. Checklists are incredibly important because checklists are a great way to try to catch any last-minute problems that you may have. Years ago, back in the 1990s, I used to fly a Cessna 172. When you fly, you have the pre-flight checklist. You may be the only one out there in the plane at the end of the runway, putting time on the engine and burning up fuel, but you have it drilled into your head, go through the checklist because you find it's better to find a problem while the wheels are still touching the ground. Because once the wheels leave the ground, it takes on a whole different characteristic. So checklists are very important, and there is one included in Annex I. The electrical safety program has to include an electrically safe work condition policy. So those of you responsible for your electrical safety programs, this is something that you're going to want to take a look at, that the requirement is the electrical safety program shall include an electrically safe work condition policy. There was a very big change to training. The section on training, 110.6, a very big change. Let's take a look at the change. There was sort of a minor text change, but then there was a very sweeping change that's very 2020 appropriate. The first change was just additional language, that instead of stating retraining, it now states additional training and retraining, because not all training is retraining. There may be something new, so there's additional training. There was a very big change as part of an informational note that now states that classroom training can include interactive, electronic, or interactive web-based training components. Let's think about this one for a minute. So the 2021 revision cycle actually began a couple of years ago, before the dreaded 2020 and all the stay-at-home and quarantining and everything. And who would have thought that now online interactive, like we're doing here, NFPA 70E now includes that as part of the training. And taking this even further, towards the beginning of the year, we actually began moving all of our training to interactive online training. Not just the streaming like we have here, but we've begun to spin up training programs that are on demand. And that's on our website. And I have a few free classes out here. So if you go to brainfiller.com/learn, that'll take you out to this part of the site. And there are several classes out here that are free. You can sign up for, you go through the modules, you take a quiz, and at the end you have your continuing education credit. A relocation of host and contract employers' responsibilities. This was relocated from 110.3 to 110.7. So this was pushed out to make room for some of the new sections. There was a new addition, a new informational note stating on multi-employer work sites, more than one employer can be responsible for identifying hazardous conditions and creating safe work practices. What is this telling us? It's really simple. This is telling us that electrical safety is everybody's responsibility. So it's not relegated to just this person or entity or this one. This new informational note is simply stating that electrical safety is everybody's responsibility. On multi-employer work sites, more than one employer can be responsible for identifying hazardous conditions and creating safe work practices. It's everybody's responsibility. A change to test instruments and equipment. Seems like a very minor change, but yet it is kind of significant. That for testing, the text operating at voltages equal to or greater than 50 volts was removed. There may be hazards below 50 volts. So the thought was, well, let's just remove the reference to greater than 50 volts because there can be other electrical hazards. So now the language is only qualified persons shall perform tasks such as testing, troubleshooting, voltage measuring on electrical equipment where an electrical hazard exists. A new addition, equipment use. Real simple, one sentence. Equipment shall be used in accordance with the manufacturer's instructions. Instructions? Really? I know it's kind of a joke around here that I'll get involved in a project and every now and then I'll get it kind of tangled up, and my wife very quickly says, so did you look at the instructions? What instructions? Oh, they're in the box out in the trash. So this is just to simply state that equipment shall be used in accordance with the manufacturer's instructions. Article 120, establishing an electrically safe work condition. There was an addition to the lockout tagout procedure. And this addition states that the procedure shall meet the requirements of applicable code standards and regulations for lockout and tagging of electrical sources. Up-to-date electrical drawings. This is always a little tricky. Whether or not you have one-line drawings, whether or not they are up to date, this is something that I have run into over and over. You may find a one-line drawing and then you look at it and realize, what's happened since it was first created? Has it been kept up to date? And the reason this is so important, one of the reasons this is so important, is when it comes to establishing an electrically safe work condition. You need some kind of a method to identify where are all the sources of electrical energy. And I've investigated cases over the years. I get involved with expert witness work and investigations. And I've had a few investigations over the years where there was a breakdown in establishing an electrically safe work condition. And one of them actually involved just ignoring the electrical drawing that showed there was a third source. Person missed it. He lived, but it was pretty bad. Had a pretty serious outcome. The lockout tagout device. There was a change made here to align with OSHA. And that's something that happens from time to time as well. That NFPA 70E will have language, but then you start looking at OSHA, and OSHA will have language about the same item, and then you realize the language is a bit different. It's like, ooh, something has to give. Well, it's 70E that's going to give. So there was a change made here to align with OSHA, and this is about a lockout device shall be permitted to be only a lock if the lock is readily identifiable as a lockout device, in addition to having a means of identifying the person who installed the lock. And the addition to this language was provided that all the following conditions exist. Only one circuit or piece of equipment is de-energized. The lockout period does not extend beyond the work shift, and the employee exposed to the hazards associated with re-energizing the circuit or equipment are familiar with this procedure. So there's a new informational note regarding capacitors and discharge. And it states that for more information on methods and procedures to place capacitors in an electrically safe work condition, see Article 360. And it specifically targets 360.3 and 360.5 and informative Annex R. These are very large additions to NFPA 70E. In fact, capacitors really weren't referenced. There were 4 minimal references, and now there is a whole article, Article 360, about capacitors, and Annex R, it's a very large annex, gets into all the details and the calculations and energy of capacitors. So it was a very big addition when it comes to capacitors. The process of establishing and verifying an electrically safe work condition. There were some changes made here. You have to determine all the possible sources of electrical supply to the specific equipment. You check up-to-date electrical drawings, which is sometimes difficult, finding an up-to-date drawing. Then it means you have to walk around and update the drawing. Properly interrupt the load. Then open the disconnect for each source. These haven't changed. And visually verify, if you can, that it has been disconnected and release stored electrical energy. Originally, for the mechanical energy, it said release or block stored mechanical energy. And this was one of these areas it's like, wait a minute, block stored mechanical energy. What are we talking about here? I mean, there's a lot of sources of stored mechanical energy. Are we talking about compressor systems? You know, what are we talking about here? And so this was just tightened up to focus on the electrical side. So the new language is block or relieve stored non-electrical energy in devices to the extent that the circuit parts cannot be unintentionally energized by such devices. And that was added to the process of establishing and verifying an electrically safe work condition. Apply lockout tagout devices in accordance with documented policy, and that documented policy must be in compliance with Article 120. And then a minor change with Item 7, use adequately rated test instruments to test for absence of voltage. That's the most critical part of this. You can't say that the system is electrically safe unless you have verified there is an absence of voltage, 0 volt state. If there's a possibility of induced voltages, then you may ground all the circuit conductors. This is done pretty regularly with overhead lines where you have the possibility of induced voltages. An informational note was added, and this informational note is about the rating and design requirements for permanently mounted absence of voltage testers, referencing UL 1436. What an absence of voltage tester is. This is a demo right here. I don't have it connected right now. But absence of voltage testers, these are permanently mounted, and they're designed to indicate, is the system electrically safe or not? Or is the particular panel or equipment electrically safe? And what happens is, when it's energized, you get red lights. And when it's electrically safe, you get green lights. And people are thinking, I'm not going to trust that. It's going to take a while. But it is beginning to gain acceptance. It's battery operated in here, so it's got its own power system and self-diagnostic. It's going to take a while. But people are beginning to accept these. I talked to a couple different safety groups just over this year before last, before I got stuck at home. And they are beginning to embrace this. Because you have what's called an arc energy reduction maintenance switch to reduce the clearing time, to reduce the arc flash energy. People wear PPE based on those settings. Oh, do you trust those settings? Similar with relays. You have different setting groups for relays. And you enable a setting group that gives you high-speed clearing, and then people will dress for that. Do you trust those settings? It's going to take a while, but the industry is slowly moving towards alternate methods to try to keep people out of harm's way. Otherwise, you're going to be up close and personal, testing for absence of voltage. You have to have on full PPE and everything when you do that until you've verified that there is no voltage. And there's a whole process, live dead live test. You test your instrument to see, make sure it's okay. Then you test for absence of voltage. Then you retest the instrument just to verify that the meter didn't fail during that process. Article 130, work involving electrical hazards. There was a lot of reorganization here, really in response to some of this material being relocated to Article 110. So it left a few holes. Some things needed to be rewritten. And we also have two sections that just aren't even being used. 130.3 and 130.6 reserved for future use. So a lot of reorganization in 130. 130.1 was rewritten because some of this material disappeared and found its way into 110. And 130.3 is no longer used. The reason for that is pretty common, that when you end up with holes in a standard, instead of renumbering everything that comes afterwards, you just make it a space holder, which is what happened here. This is pretty important right here. 130.1, that this is referencing about if you have conductors or circuit parts operating equal to or greater than 50 volts, if they are not put into an electrically safe work condition, because it's permitted in accordance with 110.4, all of the following shall apply. Only qualified persons are permitted to work on the electrical conductors or circuit parts. An energized electrical work permit is required. There are a few exceptions, but an energized electrical work permit is required. A shock risk assessment will be performed. An arc flash risk assessment will be performed. 110.4, what that's referencing are the exceptions. And the exceptions are if establishing an electrically safe work condition introduces an increased hazard, an increased risk. There are a few exceptions in 110.4. Something that I really like to emphasize, because I know this becomes a big issue, many of you look at, oh yeah, we perform energized work because of X, Y, Z, whatever, and you justify it. You have to be really careful, because what I tell people, and this is a little tough the way I'm saying it, but it's very true, that when you justify performing energized work, picture yourself stating and defending that justification in court. And I know that's a little harsh, but that's exactly how this will play out. If you elect to perform energized work, and you may have a valid reason for performing energized work, just picture if something goes wrong, there's going to be an investigation and quite likely even legal action. And if that happens, that's going to be a center focus. Why were you performing this energized? And being an armchair quarterback is always easy. It's like, well, the justification made sense at the time, but now looking in hindsight, So just kind of a perspective for you when it comes to that. The shock risk assessment. This is new, believe it or not. The shock risk assessment is not new, but the requirement of 130.4b, estimate of likelihood and severity, that is new. And this was added because there was a similar requirement when it came to the arc flash risk assessment. So to align with what we have with the arc flash risk assessment, this new language was added when it comes to the shock risk assessment. And this requires factoring in item 1, the design of the electrical equipment, and number 2, the electrical equipment operating condition and condition of maintenance. Yeah, there's a good one. The operating condition, condition of maintenance, well, that's kind of questionable too. And so, yeah, this one, I actually took this photograph several years ago. Living in the Phoenix area, I took this in the border town of Nogales, Mexico. And it was in an open market, and I saw that and thought, oh, I'll be able to use this somewhere along the way. Estimate the likelihood of occurrence of an arc flash incident for AC and DC systems. This is new. This is a new addition. Some people have been talking to me about this, and let me explain what this is about. So we have these tables, and I mentioned the tables. The first sort of version of these tables were introduced in the 2015 edition. And it lists certain tasks, and then it lists, it didn't start out this way, but now it says likelihood of an arc flash, yes or no. And so there's a lot of different tasks in there. And in general, if you have equipment where all the covers are in place, normal operation, and just operating it, it's considered basically not a high likelihood of an arc flash. But there's one in there now that is. And it's the one that was introduced for 2021. And so what this looks like, if you're going to operate a circuit breaker or a switch for the first time after the installation or completion of maintenance in the equipment, the first time operation. Why is that? There's something called normal operation, and you can have equipment, there's boxes that you check, and if it's deemed normal operation, yes, you can operate it. There's considered to be no significant risk of an arc flash hazard. And that's just operating a switch in a normal condition. But the addition is, okay, but if you're operating this switch for the first time after it was installed, or you're operating this switch for the first time after there was maintenance, that has changed now, and it's considered a risk of an arc flash. You know, is there a huge likelihood when you energize a breaker? Well, I can't contradict this, but within NFPA 70E, the rationale is yes, the first time you're operating a circuit breaker or a switch after its installation or after completion of work or maintenance, over on the far right, likelihood of occurrence of an arc flash, yes, that is a new change. An incident energy analysis. This is where you are selecting the arc rating of your protection to be sufficient for the incident energy. I sometimes oversimplify this, but I look at it in terms of, with the incident energy analysis, it's coming down to, are you going to be wearing the moon suit with the hood, or are you going to be wearing a face shield? with a balaclava sock. And so really what an incident energy analysis is all about, all of the arc rated protection has what's called an arc rating, calories per square centimeter. And you want to select an arc rating that is sufficient for the prospective incident energy that could occur during an arc flash. I have a video I want to show you. It's a pretty short video. This was one of my arc flash tests that I conducted a number of years ago. This is a switchboard, 50,000 amps of short circuit current. This would be similar to what you may experience on the secondary side of a 2500 kVA transformer at 480 volts. The switchboard itself is about 6'6" tall. It's pretty big to give you some perspective of the size. So just to illustrate what an arc flash looks like, let's take a look.
Holy nice one. That was nice.
Wow. Kind of a little secret to that video. I had intentionally drilled all the different covers and bolted them shut. I was trying to contain all the energy because we were trying to experiment to see if there's enough energy to ignite some of the materials inside. And even at that, the energy that was released was just staggering. So some will question, do the doors offer any kind of protection from an arc flash? And the short answer is you never know. I mean, so we look at it as no. And even in that case, all the covers and doors and everything stayed closed except for one small little panel that popped. And the arc flash energy, it came out anyway because it's a plasma. Plasma is a fluid, and it's going to escape through any crack, crevice, vent hole, and you could see what the result was. So working in front of this equipment, thinking, oh, the doors will protect me. Not really. The incident energy analysis is conducted based on IEEE 1584. The 2018 edition is the latest and greatest. I'm the vice chair of this group, and a lot went into it. This defines the calculation methods for calculating the prospective incident energy. This was a pretty significant change. It answered a question that many people had, and that is if you wear protection from the elements or safety equipment such as a high-vis vest, the arc rating of outer layers worn over arc-rated clothing from protection from the elements or for other safety purposes, as I said, like a high-vis vest, if it's not part of a layered system, it doesn't have to have an arc rating equal to the estimated incident energy exposure. Let me unpack this, describe it a little bit. So there was this question. If you're wearing, for example, like maybe 12 calorie PPE or 40 calorie PPE or whatever your rating is, and that's because of the available incident energy. If you have a high-vis vest, for example, and it has an arc rating very nominal, 4 calories or something like that, is that acceptable? And there was never a good answer for it. Now there is. As long as the outer layer is arc rated for protection from the elements or safety like the vest, as long as it has an arc rating, it doesn't have to have an arc rating that matches the prospective incident energy. The goal is arc rated clothing, it stops burning once the energy goes away. So once the arc flash is over, even though it doesn't have a very high rating, it stops burning. And that was the concern. If you have something that's not arc rated, it can continue to burn. And if you have that on top of arc rated clothing, that could end up causing a problem. So the question has been answered. You can wear outer layers for protection from the elements and for safety purposes as long as they have an arc rating. There was another addition, and this is about footwear. Historically, footwear has either been leather or dielectric, and now there's a new informational note that says you can have footwear other than leather or dielectric footwear. It's permitted as long as it's been tested to demonstrate that there's no ignition, melting, or dripping at the estimated incident energy level. Both of these have been added to the PPE table, 130.5G. So there is now information about the outerwear, and there's a note down at the bottom, and there's also information about the leather footwear. And there's a note down at the bottom about wearing other types of footwear if it's been tested to demonstrate no ignition, melting, or dripping at the estimated incident energy exposure. We have yet another addition, and this is to answer the question of, I call it the proverbial catch-22. and I'll explain this in a moment. But how many of you have locations, usually it's at the service entrance, where you have a service entrance and the incident energy at the service entrance is staggering? Like in this case, over 130 calories per square centimeter. There's always this question, what do you do? And the answer is de-energize, establish an electrically safe work condition. Great, makes sense to me, except part of establishing the electrically safe work condition is verifying absence of voltage, which means the potential hazard exists. And you have, in this case, over 130 calories a square centimeter. And you're going to go up and measure absence of voltage, verify absence of voltage? Really? With over 130 calories a square centimeter? So there was an addition to the 2021 NFPA 70E. And this is when you are trying to verify the absence of voltage and you have an unusually high amount of incident energy. The addition, where the estimated incident energy exposure is greater than the arc rating of commercially available arc-rated PPE. For the purpose of testing for the absence of voltage, there are examples of risk reduction methods to reduce the likelihood of occurrence of an arcing event or the severity of exposure. Commercially available ratings of PPE have gone way up over the years. On the right, that's a 140 calorie arc flash suit. That's actually my hand basically balancing it. This suit was so thick and rigid, it could just about stand up by itself. All I was doing there was just balancing it. Most people don't have PPE with that high of a rating. Examples of risk reduction methods. You can use a non-contact proximity test instrument or measure the voltage on the secondary side of voltage transformers before you make contact. So that's to give you a little bit of a check before you actually make physical contact. If the equipment design allows, see if you can verify that the switch is open, that there are gaps between the conductors and circuit parts. Increase the working distance. This sometimes may be the easiest one because the available incident energy is related to the distance between the worker and the possible arc flash. And so if you can increase the working distance, that may go a long way as well. So people may use hot sticks. You may use remote operation. There's a lot of remote operated equipment that's available now. There is remote operated equipment for legacy equipment where you attach some mechanism and then you get out of the way and you operate it remotely. That's increasing the working distance, and that greatly reduces the incident energy because incident energy drops exponentially as the working distance increases. And you may consider system design options to reduce the incident energy level as well. Where we had one table, we now have two. There was a table which has now been renumbered as 130.7C7B, and this is for rubber insulating equipment, the test intervals, the maximum test intervals. That table still exists, but it's been renumbered, and we have a new table that was added, and this is for maximum use voltage for rubber insulating gloves. Maximum use voltage for rubber insulating gloves. This is the new table right here. This gives you the class designation of the glove or sleeve, the maximum AC voltage in the second column, and the maximum DC voltage in the third column. And on the far right, the distance between the gauntlet and the cuff, the minimum distance. And that is actually this part right here, between the gauntlet and the cuff of the glove. There's a minimum distance that's required for right here. That's in this new table. The table that was here was renumbered. It's now 130.7C7B, and this is for the test intervals for rubber insulating equipment. There was another pretty significant change, and this one, I was somewhat involved with this one. Not so much in making the change, but let me explain what happened. Back with the 2018 edition, I mentioned how standards have been removed from the mandatory part of the text of 70E and had been moved to informational notes. So back in 2018, the ASTM standards for PPE testing were taken out of the mandatory part of NFPA 70E, and they were moved into an informational note. And so one of the people high up within ASTM, and I'm a member of that committee, but I'm not at the top of it. So one of the people high up within ASTM sent off an email to NFPA about the new 70E, about removing these standards, putting them in an informational note. And they made a comment about, next thing you know, we're going to be using IEC standards in there. That's not going to be good. It's like, well, wait a minute. I'm the international chair of all those standards. So then I had to put on my official hat and fire off an email back to them about, hold up, some of the IEC standards are actually a little better than the ASTM standards. But anyway, that was 2018. The IEC standards weren't part of this in 2018. But in 2021, sure enough, we have IEC standards that have been included in this list. And these are two of my standards. So yeah, they made their way in here. In fact, this is one of them right here. This is 61482-1-1. And some will refer to this as an open arc test method, which is similar to what we have within ASTM. There's a little bit of a difference because there's a term called ELIM that's a little different. But this is basically the equivalent, we'll call it, of the ASTM test methods for the global use, for the IEC standards. As far as the testing of the PPE, this is one of the labs that I've worked with. This one is over in Geneva, Switzerland. And with this lab, there are opposing electrodes and there are calorimeters. So the opposing electrodes, they're 12 inches apart, and you initiate the arc flash there, and then you have the panels equidistant around the arc source, and then you have the calorimeters that are actually measuring the energy. And on the right, this is looking into a calorimeter on a test panel right here. Article 360 is brand new, and this is all about safety-related requirements for capacitors, and it is a very large article. Has a scope, definitions, stored energy hazards, specific measures for personal safety, establishing an electrically safe work condition for a capacitor. This is different than the traditional electrically safe work condition. Capacitors have different requirements for the electrically safe work condition. And then grounding sticks. One other significant change that I want to discuss is historically in NFPA 70E Annex D, there have been equations for calculating the incident energy. IEEE 1584, traditionally, the equations have been listed in Annex D. Those were removed. I had a lot to do with this. And the reason they were removed is the equations for the 2018 edition are really complicated. And there's tables of all these different K values. There's up to 13 different K values, and there's big tables. And it's a very complex calculation method now. So the thought was, instead of putting that information in there and possibly running the risk of having it misused or really confusing people, there's information in there about what the 2018 edition is all about, but it stops just short of the equations in there. So if you're thinking, oh yeah, I'm going to get the latest and greatest, I'll just get the latest copy of 70E, go back to Annex D, I'll find the new equations. They're not in there this time around because they're so complicated. I actually have a class on that coming up the beginning of December 2020. It's a 16-hour class, and I go through all the equations and calculations. It's pretty comprehensive. There was a new F.7 that was added when you're working around battery systems. And F.7, it's acknowledging that if you're working around battery systems, there's more than one hazard. There's multiple hazards. And they may be encountered when working on batteries. So you have the shock hazard, of course, possible arc flash hazard, but you also have the chemical hazard, the thermal hazard. And so it's acknowledging that the PPE selection needs to take into account all these hazards. And there's a flow chart to help with this. Annex R is all about capacitors. And this is a very comprehensive annex with a lot of good information about capacitors and the risk assessment, determining the shock hazard, capacitor stored energy, a lot of new and very good information in Annex R, brand new annex that was added. You made it. That was a lot of material in a pretty short period of time. What I'd like to do, just in appreciation for you, sticking with me to the end here, is we have a coupon code good for 10% off. And the code is EASY10, so yeah, we're keeping it that easy. And it's valid through the end of next year, December 31st, 2021. Hoping 2021 is a little better than 2020. And so with that, it's 10% off any of the training that I do, whether it's streaming like this or our new online platform. So take advantage of it, write it down, and thanks for joining, and hope you have a great day, and take care. Hope that was informative. There was a lot that went into the 2021 edition. As I said, some of it was just cleaning up, modifications, relocations, and so forth, but there was quite a bit to it. So anyway, I appreciate all of you being here. Hope you got a lot out of it, and we're less than 3 years away from the 2024 edition of NFPA 70E. So I appreciate it. Thanks a lot. Take care, and stay safe out there. It's been an odd year. Hope to see you again.
Thanks, Jim.